Unexpected, shocking, and ultimately horrific for General Motors' reputation. That is the hidden truth behind Chevrolet's subcompact that launched on Thursday, September 10, 1970, and seemed destined to win, yet became one of the most notorious failures in Detroit history. The Chevrolet Vega of model years 1971 through 1977, the car Ed Cole believed would be GM's greatest small car answer, but that instead taught a generation why rushing advanced technology can be the most dangerous decision of all. Today we're talking about why a sleek, sharp, modern compact, styled under Henry Haga's studio that also shaped the second-generation Camaro, captivated America in its first months, won a Car of the Year trophy, and peaked near 500,000 annual sales during the oil crisis, yet fell so fast that only roughly 78,000 trickled out in the final year, pushing hundreds of thousands of buyers toward import rivals and leaving a cautionary legacy that engineers and executives still study. You'll see how a sleeveless aluminum engine, a tiny radiator, and a punishing timetable, combined with tense labor relations and early recalls, turned hope into heartbreak. And you'll hear how later fixes, hydraulic lifters, stronger valve stem seals, and Durabuild branding arrived too late to repair trust. Let's explore the origin because it foreshadows the outcome. In October of 1968, GM Chairman James Roach promised a 2-year sprint to a world-class subcompact, codenamed XP887, with a lightweight overhead cam 4-cylinder and breakthrough manufacturing, nearly half the usual development time, with razor-thin margins for cost, weight, and durability. The project was a corporate mandate, not a grassroots Chevrolet initiative, with Ed Cole backing the Vega name, an astronomical symbol of brightness, and an explicit aim to outclass Volkswagen Beetle and Toyota Corona while beating Ford Pinto to market. Speed and ambition hid risks that real owners, not lap cycles, would expose. By the late 1960s, small cars neared 3/10 of the U.S. market. Imports alone passed 1/10 and kept rising. After the Corvair's public troubles, Chevrolet needed not just a good subcompact, but the most convincing domestic answer. Ed Cole, architect of the small block V8 and Cadillac's 1949 overhead valve V8, pushed breakthrough tech and a price near $1 per pound, a headline that quietly drove aggressive cost-cutting. The hidden consequence was slender thermal margins and material choices that would prove fragile outside test conditions. On paper, the Vega was modern. A low roofline, near 50 inches, or about 127 centimeters. A wheelbase just under 8 feet, or about 246 centimeters, and standard front disc brakes when rivals often used drums. It fit cities and promised composure on long American drives. Early press runs from Colorado Springs to the Mesa, Arizona proving grounds saw cruising above 80 miles per hour, about 130 kilometers per hour, and mid-20s miles per gallon, roughly 9 liters per 100 kilometers. Yet a secret lurked. Silicon-impregnated aluminum bores and a very small radiator required careful fluid vigilance that everyday owners rarely maintained. Here's the centerpiece. The 2.3-liter inline-4, about 140 cubic inches, used an A390 aluminum silicon alloy block without iron sleeves. GM and Reynolds Aluminum had chased this for years to cut weight and cost. Sleeveless bores can succeed, but the Vega's open deck block, cast iron head to save money, and a tiny radiator with about 6 quarts, or roughly 5.7 liters of coolant, left little safety margin. Low coolant or thin oil, common when owners skipped checks, especially in heat or long climbs, meant overheating, head gasket stress, cylinder scuffing, and rising oil use. Weak valve stem seals aged quickly, oil control faded, and one problem aggravated the other until failure became common. One quirk worsened the image. The Rochester 2-barrel carburetor on higher output tunes could loosen under 4-cylinder vibration. When the top shifted, The accelerator pump could flood the engine, causing backfires that blew mufflers and heated nearby tanks enough to leak. A recall in April 1972 covered about 130,000 cars, followed by a throttle linkage recall near 350,000, and then a rear axle recall around 526,000 for possible axle separation. One recall can be managed. 3 large ones in quick succession branded the car unsafe and unreliable in the public mind. Assembly added another risk layer. Lordstown, Ohio, was refitted for high automation at 100 cars per hour, far above old norms. When GM's assembly division assumed control from Chevrolet and Fisher Body in late 1971, staff was reduced but speed held, spurring conflict and a wildcat strike in March 1972 that halted production much of the month. Quality fell, panel misalignment, leaks, rattles, just as recalls hit. Even as engineering stabilized the mechanicals, fit and finish eroded at the worst time. Rust dealt a third blow. GM's electro-deposition primer, ELPO, didn't fully coat tight cavities. Early cars lacked plastic inner fender liners. Sand, salt, and moisture attacked front fenders and lower seams, especially in the Great Lakes and Northeast, where road salt devoured thin metal within a few winters. Plastic liners arrived in 1974, with more anti-corrosion changes later, but images of bubbling fenders spread quickly. Rust looked like neglect and penny pinching, not bad luck. Performance specifics matter. Early base engines were about 90 horsepower gross, later recalculated as lower net ratings after 1972 emissions changes, with base tunes in the low 70s net by 1973 and the 2-barrel in the mid-80s net. Real-world 0 to 60 often landed in the mid to high 13 seconds. With the 4-speed and a 3.36 axle, early road tests reported quarter-mile runs in the high 19-second range at mid-70s miles per hour, about 120 kilometers per hour, with the L11 package and its handling upgrades and wider A 70 by 13 tires. By 1973 to 1975, emissions cuts took power off nearly every car, but the Vega's Course 4 magnified the loss with cabin noise that made it feel slower than the numbers. Fuel economy should have been the ace. Steady highway trips returned mid to high 20s miles per gallon, about 8 to 10 liters per 100 kilometers, exactly what commuters wanted during 1973 and 1974 gasoline lines. Yet oil-thirsty engines, blue startup smoke, and creeping temperature needles turned thrift into anxiety. Savings at the pump could not offset fear of overheating. Neighbors' stories of muffler backfires and axle recalls amplified the dread beyond what raw data could capture. Could GM have avoided the cascade? Larger cooling capacity from launch, an overflow bottle earlier, long-life valve stem seals, and conservative iron sleeves, accepting weight and machining cost, would have reduced scuffing and made overheats survivable dealer repairs, not engine replacements. GM eventually added many fixes: the overflow bottle by 1974, better warnings by 1976, and the Durabuilt 140 with improved coolant passages, a quieter head with hydraulic lifters, stronger valve stem seals, a tougher head gasket, and thermostat changes, plus a 5-year, 60,000-mile warranty, about 97,000 kilometers. The celebrated Desert Endurance demonstration later showed 3 pre-production 1976 cars, covering 60,000 miles in 60 days with only a broken timing belt. But by then, the public had moved on. Styling was outstanding. The hatchback's fastback roof, the camback's clean tail, and the sedan's Camaro-inspired face gave the most contemporary stance in the class. The optional handling package performed well on Arizona Mountain. Switchbacks out of Flagstaff where imports faltered. That contrast, excellent packaging and dynamics against fragile powertrain and rust, made the disappointment sharper. The Vega drew first-time Chevrolet buyers, then sent them to Datsun and Toyota a year or two later. Production numbers traced the arc, about 277,000 in 1971, after strike delays into mid-January, about 394,000 in 1972, about 427,000 in 1973, a peak near 460,000 in 1974 during the oil embargo, then just over 200,000 in 1975, 160,000 in 1976, and roughly 78,000 in 1977 as the Vega faded and the Monza and H-body siblings took the stage. Big success, then a steep collapse once defects became widely known. So there's an extraordinary subplot, the Chevrolet Cosworth Vega, pronounced Cosworth Vega, the rare twin-cam edition of 1975 and 1976, the first GM production car with computer-controlled electronic fuel injection from Bendix. It used a 2-liter, about 122 cubic inches, forged bottom end, stainless header, and a detuned Cosworth engineering head. Output was about 110 net horsepower at 5,600 revolutions per minute and 107 pound-feet, near 4,800, roughly 145 Newton-meters. 0 to 60 arrived in roughly 9 seconds, with a top speed about 112 miles per hour, near 180 kilometers per hour, priced near $6,000, about double a base Vega and above some V8 Camaros. Sales were tiny. 2,061 cars in 1975 and 1,447 in 1976, totaling 3,508. Advanced, smooth, and rare. It could not rebrand the nameplate. The Dura-Built era was the strongest bid for redemption. In 1976, improved cooling, hydraulic lifters, better seals and gaskets, and a low coolant warning transformed daily manners. The 5-year, 60,000-mile warranty, about 97,000 kilometers, signaled confidence. Under United States Auto Club supervision, 3 cars ran 180,000 miles combined in 60 days, through desert heat between about 99 and 122 degrees Fahrenheit, around 37 to 50 degrees Celsius, using only about 24 ounces, roughly 7/10 of a liter of coolant per car, normal evaporation for such heat, while averaging nearly 29 miles per gallon, about 8 liters per 100 kilometers. The feat impressed, but reputation turns on everyday experiences, not staged trials. The wider 1970s context mattered. Fuel shocks, emissions, and safety rules forced trade-offs, while Japanese makers scaled small 4s with high quality, and Europeans, though costly, offered durable engines and better corrosion protection. The Vega proved GM could style and tune a small car well, yet reliability became the paramount metric. The linerless block with narrow cooling margins demanded diligence most commuters would not provide. Stranded commuters became long-term skeptics of domestic compacts. Memories of oil smoke and rust lasted. Public watchdogs amplified the story. Ralph Nader criticized the Vega as sloppily crafted and unreliable, aligning with reports of fires, throttle issues, and axle risks. The car had aimed to be the most advanced, the first, and the best, superlatives that magnify praise and blame. Recalls arrived early and often, while a factory labor crisis suggested deeper organizational strain. Compressed timing and cost pressure became both motive and mechanism for failure. Inside engineering, another subtle cause emerged. Some believe early machining used excessive honing pressure on the bores, seating scuffing that later looked like alloy failure. Others note that linerless aluminum bores can thrive. With generous cooling and robust seals, the Vega might have enjoyed longevity. The integrated system, materials, thermal margin, vibration, was the issue. The cast iron head, small radiator, and secondary vibrations that loosened carb hardware created compounding weaknesses. Owners' experiences defined the verdict. In warm, dry regions, The best trim hatchbacks with the MBF41 handling package carved on ramps tracked steadily at 70 miles per hour, around 113 kilometers per hour, and returned better than 25 miles per gallon, about 9 liters per 100 kilometers. In cold Midwestern winters, owners heard valve train clatter, suffered unstable idle with early emissions calibrations, and watched fenders bloom by the second or third winter. When a car drinks oil and asks for a head gasket, drivers remember the toe, not the turn-in. Timing blunted later improvements. A larger 16-gallon tank, about 60 liters, arrived in 1974, but long lines at fuel stations had eased, and buyers wanted reliability first. The Monza and Buick, Oldsmobile and Pontiac siblings, on the same architecture, offered smoother V6 and V8 options and fresh styling. Burned Vega owners were wary. By 1976, the Dura-built engine, vented rotors, and a stronger crossmember improved the car, but the Chevette had captured the subcompact price tier. A few human vignettes echo the data. In 1971, a Chevrolet engineer took home a pre-launch hatch with the 110 horsepower tune and loved its eagerness. Friends admired the stance and verve. In August 1975, 9 drivers rotated through 3 cars for 60 days and 180,000 miles, roughly 290,000 kilometers, with only a timing belt failure. In the north, one owner watched fenders decay, then fed a thirsty engine with shop oil as a matter of routine. Proof that the car could be kept alive with care, and proof that such care was more than a new car buyer should need. Why did the Vega become one of GM's biggest failures despite more than 2 million built and strong sales during the oil crisis? Because volume masked loyalty loss. 1973 and 1974 moved metal, but warranty bills rose, service bays filled, and customers quietly vowed never again, shifting to brands that offered uneventful mornings and slower rust. The Vega is a textbook on winning the quarter and losing the decade. Yet it delivered genuine firsts. The Cosworth Vega introduced computer-controlled electronic fuel injection to GM production. Lordstown's high automation previewed modern body shops, and the linerless aluminum program foreshadowed later successful high silicon bores and advanced surfaces. Innovation sprinted, while execution limped under deadlines. The pattern recurs in industry history, but few cases match the Vega's mix of promise, scale, and consequence. By 1977, sales had dwindled to about 78,000 as the H-body coupe with smoother engines took over. Internal lessons hardened. Do not launch an all-new car with an all-new engine in an all-new high-speed plant with an all-new shipping process. All at once. Do not shave corrosion protection to save pennies. Do not assume laboratory miles predict how commuters skip coolant checks, drive on thin oil, and idle in summer traffic. In the classic pantheon, the Vega is both a beautiful artifact of early 1970s American design and a deeply instructive machine whose late fixes arrived after the public closed the book. Survivors include rare Cosworth editions with black and gold livery and an engine-turned dash, and later Dura-built cars that, kept cool and sealed, run with a civility early cars seldom managed. Many are retrofitted with iron sleeves or alternative engines, achieving the durability its shape deserved. The cultural memory endures. It taught GM the highest cost lesson of cost-cutting. For narration clarity, pronounce Chevrolet Vega, Dura-built 140, and L11 exactly as spoken, and reserve ZL1 as ZL1 or ZL1 only when referencing Camaro lore outside this story. Why did it fail in reputation while winning early sales? Reliability compounds. Every flawless morning builds confidence. Every tow erases 10 commutes. Narrow cooling margins and fragile seals collided with human nature, and when the car punished normal behavior, the public punished the brand. In the end, the Vega is GM's most revealing small car saga. A brilliantly conceived compact with standout styling and ambitious metallurgy, undone by a rushed schedule, thin thermal and corrosion margins, and a cascade of recalls that no advertisement could overcome. That is the truth behind the unexpected rise and shocking fall of the Chevrolet Vega. And it is why the name ended after 1977, even as its lessons shaped every small car that followed.